In this video, we are going to learn how to resolve a vector into its horizontal and vertical components. And so this is one of the things that you end up using a lot when you're working with vectors. So this example here has a vector with a magnitude of 85, and it has an incline, an angle of 28 degrees with the horizontal. And so it wants you to resolve the vector into its horizontal and vertical components. Okay, so 28 degrees would be something like this. And so the magnitude of this vector is 85. And then this is 28 degrees. And so what it means when it says to resolve this vector into its horizontal and vertical component, it's asking you to find this vector. This is its horizontal component. And then this vector would be its vertical component. So it's like, what is the horizontal vector and the vertical vector that if you added the two together, you would get the vector here as a resultant vector. So you're really wanting to find the magnitude of this vector and this vector. We know the directions. This one's horizontal and this one's vertical. Okay, and so what we want to know is what are the magnitudes of these. Well, this is actually pretty straightforward. Okay, so this is the hypotenuse of a right triangle. And this is like the opposite side. So we could call this is the adjacent side, this is the opposite side. We could call that X and that Y if we wanted to. And then we would get that the cosine of 28 degrees would be equal to the X over 85. And the sine, I'm going to leave a space here, the sine of 28 degrees would equal the y over 85. So what I can do is I can solve this for x, and when I do, I get the 85 times the cosine of 28 degrees, and this would be the y would be the 85 times the sine of 28 degrees. So to resolve these, basically, to get the horizontal component, it's just the magnitude of the vector times the cosine of the angle. And then the vertical component is the magnitude of the vector times the sine of the angle. So 85 times the cosine, 85 times the cosine of 28 degrees gives me 75, so approximately 75.1, and then 85 times the sine of 28 degrees is approximately 39.9. So this is the horizontal component here, this is the vertical component here. Okay, so if you could almost really generalize this as follows: if vector v has a magnitude of v, absolute value of e, and absolute value of v there, and angle of theta, and by theta I just mean the angle with this horizontal here going this direction, kind of like a unit circle, then what you get is that the horizontal component is equal to the vector, the magnitude of the vector times the cosine of theta, and the vertical component is the magnitude of the vector times the sine of theta. And it really very similar to the polar coordinates with x equal to r times cosine theta, y is equal to r times sine theta. Very similar to that. So that resolves the vector into the horizontal and vertical components. So in this next example here, we're just going to do an application of this. So this says a lawnmower is being pushed with a force of 24 pounds in a direction that is 37 degrees down from the horizontal. How much force is being exerted in the horizontal direction? So this is kind of like there's a lawnmower. Right, and then the person is pushing the lawnmower, and there's a downward force here of 24 pounds, and it wants to know how much of this force is going in the horizontal direction. Okay, not so much concerned about the vertical direction. So how much of the force is actually moving the lawnmower forward. Okay, so I'll go ahead and use this theta. So the theta is 37 degrees. So this angle is 37 degrees. Now if I use this angle, like the one with a unit circle, that would be okay. That would give me the same cosine value. Okay, because the x coordinates are the same in the first quadrant and the fourth quadrant down here. So either way, you get the same if you use 37 or if you use the angle that goes all the way around. Either way, you get the same horizontal component. Notice though, if you use this angle, you would get a downward vertical component, which actually makes sense because it is downward. So using this angle would actually give you the right sign on the vector. If you use 37 degrees, it would be a vertical vector going upward. So using the actual rotation around the unit circle is going to give you the right sign on your vector. But in this case, either way here, the cosine is going to be the same. So it's just the magnitude of the vector times the cosine of the angle. And that gives you the vertical component. So 24 times cosine of 37. And it's like 19.2 pounds. So if the person is pushing the lawnmower with a force of 24 pounds and it's going down at an angle of 37 degrees, then this is how much of the force is actually pushing that lawnmower in the forward direction. Okay, the other is going downward. So so there you go. That's the idea of resolving a vector into its horizontal and vertical components. Usually whenever you resolve a vector, it's in terms of two vectors at right angles. So we're going to do an example here where it's not necessarily the horizontal and vertical components. They're going to be angles that are parallel or perpendicular to a ramp. And it's going to be the same idea, but the setup is a little bit different. And this will be the final problem in this section. So I'm going to do one, and then I'll have you do one.